Good morning to everyone. Welcome to our channel. Today I am going to explain you about the 10th class physical science that is related to chemistry. I am going to explain it. It is published by the government of Telangana. Some chemistry topics are chemical equations, acids, bases and salts, structure of atom, periodic table, chemical bonding, principles of metallurgy and carbon and its compounds. Today I am going to explain about the structure of an atom. Several scientists have proposed different atomic models. In that, some major atomic models are, first one is Dalton atomic model. You might have heard about this Dalton atomic model in your earlier standards, that each and everything, that might be a pen, that might be a book, everything that is made up of matter. And that matter is made up of some small tiny particles, those are known as atoms. He said that atom is a round solid sphere or a ball which is indivisible. He does not know about the presence of the subatomic particles inside the atom. What are the subatomic particles here? Those are called the electrons, protons and the neutrons. Why he does not know about the subatomic particles? Because at his time of his discovery, the electron microscope was not invented. We know up to cellular level we use only the simple microscope and the compound microscope. So the drawback here is he does not know about the presence of subatomic particles. Next model is J.J. Thomson atomic model. Here he discovered the electrons. He said that atom is a positive ball with the electrons embedded inside the atom. And this model is also called as plum pudding model and watermelon model. Plum pudding means raisins in cake. Watermelon means, see, this is the watermelon where this red portion, the red portion completely is positively charged, where the seeds were represented as the electrons. The drawback here is he did not say where exactly this positive charge is concentrated, whether it is present here, here or somewhere. He said that complete red portion is made up of the positively charged. This was the drawback in the Thomson atomic model. Next model is Rutherford atomic model. Here he discovered the nucleus. He said that it consists of a positively charged nucleus and the electrons revolves around the nucleus in the particular orbits. Here the electron revolve in any orbit at any distance. This is also called as planetary model. As the planets revolve around the sun, in the same way the electrons also revolve around the nucleus in the fixed orbits, not orbitals, okay? The drawback here is, according to classical physics, if a charged particle like electron, when it moves continuously, it loses its energy and fall into the nucleus. But this is not happening here. Why? Because atom is stable. Here the drawback is he could not explain why the electrons are not falling into the nucleus. Next model is Bohr's atomic model. In this model, he said that it consists of a positively charged nucleus. This is the improvement from the Rutherford atomic model by adding quantized energy levels. It consists of a positively charged nucleus and the energy shells are present here. Here the electrons are present only in this particular orbits. These are called as orbits. Here the electron jumps from one energy level to another energy level. This is the ground state and this is the excited state. When the electron jumps from the lower to higher and higher to lower, it releases energy. Here energy loss is not continuous. It happens only in steps, means quantized jumps. It can only exist in fixed energy levels. It cannot go beyond lowest n is equals to 1. This is the first energy level. It cannot go beyond it. So the electron will not fall into the nucleus. Because energy is not continuous, energy is lost in quantized way. By step, it loses its energy, so the electron is not falling into the nucleus. But this model is only applicable for the only hydrogen atoms. Hydrogen atomic number is 1, number of electrons is 1. So it is applicable for the atoms with 1 electron, not applicable for more electron atoms. It also does not explain about the fine splitting. Means this is one energy level. Inside this energy level, there are also some sub energy levels present. It does not explain about this fine splitting. Now next atomic model is Bohr-Sommerfeld atomic model. Here electron move only in the circular orbits, we know that. But in Sommerfeld idea, electron's path is not always circular. These are not always circular. He said it's also consists of elliptical orbits. Okay. Sommerfeld said that electron path is not always circular. It can also be elliptical, means oval shape. He said that electron moves in both circular and the elliptical orbit also. The electron moves only in the circular and the elliptical paths. Suppose for each energy level there are multiple orbits. This is n is equals to 1, n is equals to 2, n is 3, n is equals to 4. In that, if n is equals to 1, it has only one orbit. Means only it has circular orbit. Next, if n is equals to 2, it has two orbits. One is circular, one is elliptical. If n is equals to 3, it has three orbitals. One is circular and two are elliptical. If n is equals to 4, they have four orbitals. Means one circular and three elliptical orbits are present. More orbits means more energy variations. Because of this, we can see the fine splitting. Because of this elliptical orbits, we can see the fine splitting here. And the last one is quantum theory. He said that the atom does not consist of a fixed paths. It only says this is a positively charged nucleus. He says the atom don't have this energy shells or orbits like this. A cloud-like region that is present around the nucleus. This is 3D region that is present around the nucleus, which is called as orbital. Here, what is orbital? The finding probability of an electron is maximum here. Means electron present only in this particular here area. 90 to 95% there is chance that the electron is present only in this particular area. This quantum theory explains that line spectrum, fine splitting, multi-electron atoms, and it also gives the shapes of orbitals. This theory is developed by Planck. Here it explains everything about the electron. And do this atom have a definite boundary? No, it is not having a clear boundary here. This is just a cloud-like region. And don't get confused with the orbit and orbital. Orbit is a 2D region. This is the 3D region. It is like a circular path. Example, like a railway track, where the train goes only in this particular direction. This is like a cloud-like region. Suppose this is a cloud-like region. If a bird enters into this cloud, it can move anywhere in this cloud. So this is the probability that the bird is present only in this particular area. In the same way, the electron is present only in this particular area. And it is not applicable for the multi-electron atoms. Means it is only applicable for hydrogen, which is having one electron. It is not applicable for the more electron atoms. Here, any type of electron if we take, it is applicable. It also says the shape of the orbital. Suppose S is spherical in shape, P is dumbbell, D is double dumbbell, F is complex shape. We know this. Okay. Spherical means like this, dumbbell means like this, double dumbbell means in the clover shape. Now this is the spherical orbital. Now the electron can move only in this particular area. Suppose dumbbell shape means if the orbital is present in this way, sometimes the electron moves in this area, sometimes the electron moves in this area, but most of the time the electron is present in this particular area. So it is in which shape? It is in the dumbbell shape. So the shape of the orbital is dumbbell. Now this theory is explained by two scientists, that is Heisenberg, another one is Schrödinger. First one is Heisenberg. Here he says that if a particle having wave nature and it is moving, it is impossible to determine its exact position and momentum at the same time. Suppose we take the particle, it is present in this particular position and it is moving with a particular speed. If we calculate its exact position, we can't calculate with how much speed it is moving. So this is explained by the Heisenberg. This is explained by a formula, that is delta x into delta p is greater than or equals to h by 4 pi. Delta x is the uncertainty in its position. Delta p is uncertainty in momentum. Momentum is equals to mass into velocity, means speed. It is related to speed. If we know the exact position, we can't calculate its exact speed. Okay, this is how related. This is Planck's constant. And what do you mean by if a particle having wave nature? What do you mean by this? Suppose if you want to make you understand about this, let me see the de Broglie's hypothesis. What do you mean by this particle having wave nature? In order to make you understand this, you need to know about this de Broglie's hypothesis. Here he said that each and everything in our universe that is made up of matter, and that matter behaves in two ways. One is wave nature, another one is particle nature. Suppose in this universe we have micro objects and macro objects. Macro means it may be ball, pen, something. Suppose if we throw this ball to a particular target, does it go like a wave? No, it is not going like a wave. Okay, why? Because the macro objects wave nature is negligible, and we have the particle nature. We don't have this wave nature. We have the wave nature, but it is negligible here. Here we have both the wave nature and the particle nature. So for macro objects like a pen or ball, the wave nature is negligible, so that if we throw to a particular target, it goes directly to there or somewhere near that. It acts like a particle there. For micro objects like electrons, microparticle, that is electron, in this, if we take this electron, it already moves in the form of a wave. In order to see this electron, we use the light by the electron microscope. Okay, when we apply this light here, this is in the form of photon. When we apply this, these electrons absorb this energy, this light energy, and these get excited or move to the other direction. by measurement itself only, we can't calculate its exact position where the electron is present. So we can't calculate its exact position and exact speed at the same time. Individually we can calculate where the electron is present exactly, we can calculate, and exact speed, with how much speed it is moving, individually we can calculate, but simultaneously at the same time we can't calculate both of these. Okay, this principle supports the Heisenberg uncertainty principle. Next one is the Schrodinger equation. These two, this Heisenberg uncertainty principle and the Schrodinger equation, are not opposite. They support each other. Okay. This Heisenberg uncertainty principle, what it said, that you cannot measure the presence of the electron exactly. So he said that, so instead of that, let us find the probability where exactly the electron is present. We can't say exactly it is present here, but we can say where in this particular area, like a probability where it can be found here, somewhere in this area only it can be found. So we will find the probability of the electron. This is said by the Schrodinger. He said that, suppose if we take a fan, you cannot know the exact position of the blade at each moment. That is said by the Heisenberg, but you can say where it is likely to be. Okay. In this particular area it is present. We cannot say here exactly it is present here. We can say it is present in this particular area. Now Schrodinger gave an equation that H cap psi is equals to E psi. This is the Hamiltonian operator. This is psi. This is energy. This is also psi. In order to make you understand this, suppose we will take the two digits, that is 2 and 1. When we keep these two digits side by side, does we get any result? No, we are not getting any result. When we use the mathematical operators here, then we are getting the result. Okay, we got the result also in the form of digits, but in different form. Okay, now we use the same analogy here. Here this is the Hamiltonian operator, is the complex mathematical operator. You think this is as a digit. So we use this mathematical operator on psi. The result we are getting also in the form of psi. Okay, here the result these are the digits, we got the result as in the form of digits. Here we use the psi, the result is also in the form of psi. This is the constant. We are getting the psi answer we are getting the psi. Okay, this psi individually has no meaning. When we square this psi, we are getting the answer in the 3-digit value, like 1 1 1 2 something. We are getting the result in the form of digits. These digits gives the complete information of the electrons. Okay, these digits itself are called as quantum numbers. If you like the video, please do like, share and subscribe.